All right, so what Addison and I are going to talk about is scalability in data centers. So in data centers, there's a lot of data to move around and collect. And as they've gotten bigger and bigger, we've seen our overall architecture to handle these massive data volumes change. And what I want to do is walk you through this architectural evolution. Now, as a quick disclaimer, the numbers and things that I'm going to be sharing, they're very specific to the application that we built and the environments that we're testing in. You might have different numbers based on your unique use case, but the overall lessons that we've learned here are something that we feel were worth sharing. So here's where we started. For us, a million tags in a data center is an extra small to small data center. For a lot of people, when you start talking about millions of tags, they go, whoa, this is a really big enterprise already. But for us, this is a starting point. Now, when we started doing these smaller data centers, something like this worked. We had I/O gateways, we had a broker, and we had a central gateway. On those I/O gateways, we had 200 to 300 PLC connections, mostly doing Modbus, and around 400 to 500,000 tags per I/O gateway. At that central gateway, we're able to catch around a million tags in engine. We're able to do our historization, visualization, alarms, and all of the data aggregation comfortably. The system's stable. If we had to do a transmission refresh at an I/O gateway, things didn't start to fall apart. Everything was nice and clean, but then we had to start getting bigger. What we found was with the way the app was structured and with the technology available to us, we were able to get to a stable state at around 2 million tags. For us, this firmly sits in the realm of like a small data center. And we knew that we needed to get a little bigger. And as we were testing out our application and pushing the limits, we broke something. When we added that fifth I/O gateway, pumping an additional 500,000 tags into the central gateway, we started to see some performance degradation. Whenever we brought that new I/O gateway online and it did its rebirth, that central gateway catching all of those new tags was actually overwhelming the internal SQLite server. So it was interesting. We worked with the IA folks and we discovered like some true like software limitations. But through that, as we were working with our IA friends, we through some brainstorming sessions, we landed on a prescribed scale out architecture. So this is where we ended up. For a lot of you, if you've looked at the server sizing and architecture guide, this should look familiar. This architecture is something that we identified as potentially being able to handle our needs, but there was a really big risk that the team identified. The app that we had built was structured around that original architecture, and they were preparing for the worst with regards to overhauling the application. This is where the true like scalability of Ignition came into play, and we ran into some really good news. When we started to test this new architecture, the team was pleasantly surprised at how Ignition as a platform was able to adapt to the new architecture with minimal rework. Something that we thought would actually take months to transition to and test out this architecture, it took just weeks instead. So what we ended up having is a clear path forward for horizontal scaling for our system. Ultimately, our data center platform, we need to be able to hit tag counts of like 20 million. So we're not talking about a small amount of data here. And in the data center world, if you're familiar, it's a lot of rapidly changing tags and it's a lot of really quick control that needs to happen. So what we ultimately landed on was this state where we could horizontally scale as needed. And at this point in time, we haven't figured out what the next breaking point is, but all of the early returns since transitioning to this new architecture have our customer really happy. So kind of to summarize this initial piece, like Ignition as a platform, it allowed us to scale our ability to collect and gather and centralize all of this data. We had to do minimal rework. We had a clear scaling plan. And ultimately, it led to Vertech having a deeper understanding of how Ignition as a platform functions under the hood. And most important, we had a happy customer. But something that, like, when you start scaling out, it's not just about how big you can grow. You must also be able to maintain that system. And I'm going to pass over to Addison here to carry on.
Thanks, Alex. So yeah, as Alex mentioned, maintainability in these scaled environments is also extremely important. Everything that we've shown up to this point was developed in Ignition 8.1. And Ignition 8.1 leaves something to be desired from a maintainability standpoint, specifically the internal SQLite database that is kind of present on all those gateways. And that makes things really difficult to maintain. You have to take a lot of gateway backups. You have to do a lot of things manually. And as we move into this more digital age, we are really starting to look more at these CI/CD tools that a typical IT stack would usually have, and this idea of architecture as code to being able to deploy these things. So it's easy when you have one or two gateways to be able to maintain this stuff manually, but when you start to deal with dozens or even hundreds of these gateways, you really want to start to be able to work with these things as code. So what you see here is actually a very realistic architecture diagram with a lot of the different technologies that we would use in our typical tech stack. And all of this in 8.3, we've now been able to throw into Docker containers and manage this all from a central GitHub repository. So now instead of having to go to all of these different environments and make changes manually, we can basically with one click go and deploy to this entire architecture. And 8.3 has made that incredibly simple. If you go to the next slide, the other thing that 8.3 has allowed us to do is better source control. So one of the best features that we enjoy about 8.3 is the different deployment modes that the gateway allows you to do. So we can now have that architecture that was on the previous page be deployed multiple times across multiple different environments. So we now have a dev environment, a build, a QA, a stage, and a prod environment that are all centrally managed by a Git repo, and it can all be pushed to basically with one click. So Ignition in 8.3 has made this incredibly simple, incredibly simplified things. The containerization and the deployment of the modes specifically are what's allowing us to not only scale the environments, but also scale the maintainability of the application. And the question always comes up, well, what's next? Like where can we go from here? And what does the future look like? So today, one of the things that we're using in a lot of our data center architectures is a graph model. If you've ever worked with these graph models before, they're very tedious to generate, and we use these graph models to generate all of our UDTs and tag structures inside of Ignition. One of the ways that we're looking to kind of scale this out in the future is to start make use of AI tools and LLMs to actually generate those graph models for Ignition so that when we go to a new data center site, we now can not only have the entire architecture distributed as code, but now also the graph model itself too, from something like an LLM that can parse it from PNID diagrams, PLC programs, electrical schematics, and any standards that you have. So again, this is really where the future is going for containerization and standardization and orchestration. So, and that's kind of our data center project. I'm going to shoot it back over to you, Reese.
Sure. Yeah. Thanks to both of you. And I just want to underscore what Alex, you mentioned at the beginning as, when you start getting into millions of tags, it's really, really important to understand that one size does not fit all, or one methodology does not fit all, because even something as simple as, hey, of my million tags, 1% of those are changing at any given second versus 5% of those are changing at any given second. If you're talking about a 10 million tag system, that is a significant difference. So those are the kind of conversations that myself and other sales engineers here at Inductive Automation have on a regular basis, conversations with end users. So we're happy to have those conversations. Just let us know. Reach out to your account executive. One thing I did want to mention before we move on to the next project here is, while we're talking about it, there's a couple questions about polling rate as well as tag changes per second in that architecture. Do you guys have any quick kind of general idea around those numbers?
So in this particular environment, depending on the tags, we have tag groups of like 1 second, 5 second, and in some cases 10 seconds. But overall, we have a 20 to 30% second over second tag change. It's the data centers have a lot of values and a lot of things that are moving very, very quickly. And in a lot of situations, there's even like sub-second control of what's going on from a heating and cooling perspective, power distribution, all of that. So that's why some of those IO gateways, they might be a little bit smaller than people anticipate. And it's because they're having to make all of those connections and gather all of that data a lot faster than maybe in a typical manufacturing environment.
Perfect.
Yeah, in some of the data center stuff that we're doing now as well, we're starting to look at some power distribution stuff that is on the millisecond time frame. So even shorter than 1 second in some of the architectures that we're seeing now as well.
Yeah. And again, that's a conversation that we can certainly have. Everybody's a little bit different, and I talk to people every single day, all day about this stuff. So happy to have that conversation.